a beauty from Anderson, full and straight.
Have you ever wondered how a cricket ball seems to have a mind of its own, altering its trajectory midair and leaving batsmen stunned at the crease? Well, let me tell you that this is not some sort of sorcery, but rather fundamental physical properties at play. Hello, my name is Ishan Agarwal and welcome to the first episode of Phy-ket We Bowl. Today, we are going to be diving deeper into the science behind swing bowling and learning how you can use this knowledge to your advantage. Moving on, why does a cricket ball actually swing? Well, the answer to that lies on the surface of the ball. The cricket ball has two distinct sides that allow for swing bowling to happen: a smooth or shiny side and a rough side. Let's start with the shiny side. When the ball is in motion, the air flows smoothly around it. We call this laminar flow, where different layers of air don't interact and disturb each other. As a result, the air separates early from the ball, creating a region of relatively high pressure around the shiny side of the ball. Now, let's switch to the rough side. Here, we experience turbulent or chaotic flow, where many layers of air mix together chaotically. This turbulent flow leads to a late separation of the air from the ball, which results in lower pressure on this side. The separation point depends on where the air's velocity reaches zero. In turbulent flow, many layers of air interact with each other, resulting in the constant replenishment of the air's velocity. This means that the separation point for the rough side is at a later point on the ball as compared to the shiny side. The difference in the two pressures causes a force from the higher pressure side to the lower pressure side, and this is what we call swing. In simple terms, the ball swings from high pressure areas to low pressure areas in the direction of the rougher side. So, if a bowler decides to keep the rough side away from the batsman towards the left hand side of the screen, the ball will move away from a right handed batsman. This is called outswing. In the same way, if the bowler decides to keep the rough side facing towards the batsman, the ball will move into the batsman. This is called inswing. But it is important to know that at the start of a cricket match, both sides of the ball are completely smooth. In order to create a difference in the two sides, players allow one side of the ball to roughen up while they apply sweat or saliva to the other side of the ball and rub it with their trousers, which ensures a smooth coating. Now, for swing to occur, the seam of the ball must remain upright, but it unfortunately doesn't in its own natural flight. To combat this, fast bowlers impart backspin on the ball as it leaves their hand. This backspin keeps the seam upright and allows the magic of swing bowling to happen. But controlling backspin is no easy task, and this is what makes swing bowling so challenging. Another concept that comes into play is called the Reynolds number. This is crucial to understanding whether airflow around the ball will be turbulent or laminar. The Reynolds number of a sphere can be calculated using the speed of the projectile, the diameter, and the viscosity of the medium it's traveling in. For a cricket ball with a diameter of 7.2 centimeters moving at 30 meters per second, the Reynolds number is approximately 140,000, and a number greater than 200,000 results in turbulent airflow. Here's where the magic of fast bowling comes into play. Fast bowlers can increase this Reynolds number by increasing the speed at which they bowl. That is why we often see the most significant swing from the fastest of bowlers. And there you have it, the science of swing bowling unraveled. If you enjoyed this episode, don't forget to leave a thumbs up. I'll see you in the next one.